Good evening and thank you for joining me. Today I want to discuss with you two theories that are relevant in the learning process. These theories are the cognitive load theory and the cognitive theory of multimedia learning. These theories help support the learner's cognitive capacity, which is the total amount of processing that can be maintained by the learner's working memory at any one time. Cognitive capacity is the premise for both of these theories. So please pay attention as I go into more detail. I want to begin with the cognitive load theory. This theory states that the working memory can only hold a limited amount of information. Once the working memory has reached its maximum capacity, learning has stopped, and then the learning outcome becomes negative. The basis of the cognitive load theory is to take information and offer it to the learner in small chunks or with frequent breaks. This concept is what makes this theory effective in the learning process. Now here is a model of the cognitive load theory. And as you can see, the information comes in through the sensory memory, which transfers it to the working memory. Since it's already been determined that the working memory only has a limited capacity for storage, before it overloads, it encodes that information and sends it to the long-term memory. While in the long-term memory, that new essential information is organized and combined into knowledge and then retrieved back by the working memory. While in the working memory, it's rehearsed for future use. With that being said, here you see information is lost in the sensory and the working memories because it's already been determined that that information is no longer important to the learner. This theory has three categories of cognitive load which factor into the process of student learning. They are the intrinsic cognitive load, the extraneous cognitive load, and the germane cognitive load. The intrinsic cognitive load is determined by the number of interacting elements within the material and the individual's prior knowledge. Therefore, it depends on the individual himself. The extraneous cognitive load is how the material being learned is presented. In other words, it depends on the presentation of the material. And then there's the germane cognitive load. It refers to the actual learning process or the mental aspect of the learning material. The germane cognitive load depends on how the student processes the learning in their mind. Now, in order for meaningful learning to take place, we must manage the germane load, maximize the intrinsic load, and minimize the extraneous load. If we can efficiently regulate these categories, then our students effectively learn and understand new material. I hope you have a better understanding of the cognitive load theory, because now I'm about to move into the cognitive theory of multimedia learning. The cognitive theory of multimedia learning basically states that students learn deeper with words and pictures than with just words. Just as in the cognitive load, the cognitive theory of multimedia learning also has three demands which affect the cognitive capacity. These demands are comparable to the three categories in the cognitive load. These demands are essential processing, which is equal to the intrinsic load, the extraneous processing, which is equal to the extraneous load, and the generative processing, which is equal to the germane load. This theory is very similar to the cognitive load theory because in order for meaningful learning to take place, we must manage the generative processing while maximizing the essential processing and eliminating or minimizing the extraneous processing. These processes are based upon three assumptions. And as we look at the model of the cognitive theory of multimedia learning, it should not be hard to see these three assumptions. They are dual channels, limited capacity, and active processing. All three of these are depicted with how students learn. Dual channels is the first assumption. And it is the concept of students learning through two processes, visual and audio, which means adding pictures with context enhances the student learning. The next assumption is limited capacity. It refers to students only being able to process a limited capacity of information through each channel at one time. And finally, we have the active processing assumption. This assumption denotes that in order for students to be actively engaged in their learning, 3 processes must take place within their minds. Number 1, they must select the relevant words and images from the material. 2, they must organize those relevant words and images from their selection. And 3, they must integrate that new information with their prior knowledge so that it can be redistributed as motivation and metacognition for the student to process the material they are learning. Therefore, active processing involves selecting, organizing, and integrating. Now allow me to discuss a few multimedia instructional principles that are used to minimize the extraneous processing so that effective learning may take place. In order to reduce the extraneous processing, we must eliminate all the outside or extra distraction from the material. As we look at an example, it will demonstrate each of these 3 principles that I want to focus on. They are all essential in removing the extraneous processing. This is a diagram of how a hurricane forms. In this diagram, I will point out each of the multimedia instructional principles and explain them to you. The first principle I want to point out is signaling. Signaling is important because it points out or signals the relevant information. Signaling is effective because it cues the important information in the multimedia lesson. The second principle is spatial contiguity. Spatial contiguity is placing text in close proximity with the illustration. Spatial contiguity eliminates all the additional distractions because it makes the relevant information easier to see for the learner. And finally, we have temporal contiguity. It is placing the text and the image at the same time. As you can see here, the text appears simultaneously with the picture, which eliminates any outside distractions. Temporal contiguity is beneficial because it supplies the learner with only the material needed for successful learning. The last thing I want to talk about is refutation. Refutation is defined as an action of proving a statement or theory to be wrong or false. It deals with misconceptions and information that is counterintuitive to a learner's prior knowledge. In science, we're learning about matter and gravity. And as you can see in this example, the big misconception with gravity is that larger objects fall faster than smaller objects. We know that it's proven that all objects fall at the same rate, regardless of their size. My students and I went through several experiments over the last 2 weeks before they would even accept that this is true. But even then, some of them still don't believe it. Since it goes against what their prior knowledge tells them, it's going to be difficult to get them to see differently. And there we have it. We've come to the end of this workshop. I hope now you have a better understanding of the cognitive load theory, the cognitive theory of multimedia learning, refutation, and several instructional principles that help in reducing the extraneous processing. Thank you for joining me, and have a wonderful evening.